Okay, in this video, we are going to look into controlling a three-phase brushless motor using a microcontroller. Now these motors are fairly common. You see them on drones, and you can buy them online, and they're fairly inexpensive. And when you buy one online, it will come with a ESC, electronic speed controller, which you can see here. Now the input to this controller is a DC voltage, so the red wire is plus, the black wire is minus, and that comes from our LiPo battery, like a 3S, which is 11.3 volts. So we feed DC power into the controller. The output will be a three-phase signal, which is feeding our motor. Now to control the speed of the motor, there's a control wire that's fed into the ESC, and it has three wires. And they're color-coded black, red, and white. So black is ground, red is 5 volts, and that's actually an output, and the white wire is a control wire. So we hooked it up to a microcontroller, and we can feed some control signals into the white wire, which will be fed into the ESC, and that will control the speed of our three-phase brushless motor. Okay, here are the control signals coming from our microcontroller to control the speed of our motor. So for minimum speed or stop, we feed a 1 millisecond pulse every 20 milliseconds into the ESC, and for maximum speed, we send a 2 millisecond pulse every 20 milliseconds. So every 20 milliseconds equals 50 hertz, so we're going to update our speed 50 times a second. So if we send a pulse from 1 millisecond and we gradually increase it up to 2 millisecond, we can control the speed of the motor from our minimum or stop into our maximum speed. Okay, here are the three motors that I'm using on my tricopter. Now on the side of the motors we have some numbers labeled. Now the top number is the size of the motor, that's the stator height and width, and the bottom number is the kV rating of the motor. That will give us our maximum RPM. So a 1300 kV rated motor times the voltage input. So for a 3S LiPo battery, that's 11.1 volts. So 1300 kV times 11.1 volts will give us 14,430 RPM. So that's our maximum RPM under no load. Now we can get different motors with different kV ratings. So the higher the rating, the higher the RPM, but the lower the torque. So there's a little bit of a trade-off there. So that's what the numbers mean on the side of our three-phase brushless motor. Okay, the control wire to the ESC is not connected to anything. It's not connected to my microcontroller. And if we power up the ESC, which will power up the motor, we'll get an audible feedback. So I'll power it up. Now the continuous beeping that we're getting, it's telling us it doesn't see any signal because I don't have it connected to the microcontroller. So that's our feedback. So next we'll actually hook it up to a microcontroller and we can control the speed of our brushless motor. Okay, I have my Nano connected up to my ESC and it's running some code, so it's feeding a 1 millisecond pulse every 20 milliseconds into the ESC. So we'll power it up and we'll listen to the audible feedback. So we got 1, 2, 3, then we got three beeps, beep, beep, beep. That means it's seeing a LiPo 3S battery, so it's 11.1 volts. And then the next beep means it's okay to go. I'll do it again. I'll power it down and power it up. And we'll listen to the 1, 2, 3, then the 3 beeps, then the long tone. So that means we're ready to go. Now I have it mapped to my keyboard. So when I do the up arrow, that's an 8 key on the keypad, it's going to increase the pulse width, and we'll get some movement. So there's the speed of the motor. I can take it down with the down key, down arrow. Now I mapped my home key to maximum speed and my end key to minimum speed. So I go home. That's a 2 millisecond pulse every 20 milliseconds. Hit end. That takes it down to 1 millisecond pulse every 20 millisecond. So that's my high speed and my stop, and then in between I use my up arrow so I can take it up slowly. To hold it down, I can take up the max and then bring it down, slow speed, and then stop. Okay, here's the wiring setup from our Nano to the ESC, our electronic speed controller. So I'm using GPIO pin 9, as you can see here, and it's coming down and it's hooked up to the white wire. That's our control wire into the ESC. And the black wire is ground, and I have that connected to the common ground to the Nano. So now all we have to do is feed a 1 millisecond pulse or a 2 millisecond pulse down the GPIO pin 9 into the control wire, the white wire, to control the speed of the motor. Okay, so I will be using timer number 1 in the microcontroller to generate our 1 millisecond and 2 millisecond control pulses. So we start off with a system clock, which is 16 megahertz, and we divide that down by 64 through a Prescaler, and that'll give us 250 kilohertz into the timer counter, which is a 16-bit. So we'll count from 0 to 65,535, which you can see here. So we'll count from 0 to 65,535, it will roll over and drop to 0. Then we'll start counting again up to its top value of 65,535 and drop down to the bottom value. It does that over and over again. So we're going to have a period of 262 milliseconds. Now that's way too long. We need a period of 20 milliseconds. So 250 kilohertz divided by 50 hertz will give us a count of 5,000 for a 20 millisecond period. So we take 4,999 and we put that into the input capture register, which will change our top count right here to 4,999. So now it's going to count from 0 to 4,999, and when it hits 5,000 it will roll over and drop down to 0. So that will give us a 20 millisecond period between our pulses, our 1 millisecond and our 2 millisecond pulses.
Okay, so next we have to set up our timer number 1 for fast PWM, which is mode 14. So if you look down on this chart, mode 14, it's fast PWM. The TOP, the top is the ICR1, input capture register. And if you look at the very top, the bits that we have to change is a WGM 10, 11, 12, and 13. And if we go down to the bottom, 14, so it's 0, 1, 1, 1, starting from the right, going to the left. So there's two registers we have to set up, and we'll get into that later, to set it up for fast PWM mode 14. So next, we have to set up the Prescaler to divide by 64. So we're using bits CS12, CS11, and CS10. And if you look at the chart, it's 0, 1, 1. So that sets up the Prescaler to divide by 64. Okay, so here are the two registers that we have to set up for fast PWM and mode 14, and to set up the Prescaler. It's TCC-R1A and TCC-R1B, so these are control registers. And when we look into the code, we could see how these are being set up.
Okay, next we're going to have a look at mode 14, which is fast PWM. So we changed our top value to 4,999 by putting it into the input compare register. So now the counter is going to count from 0 to 4,999. It's going to roll over and then drop back down to 0 again. Now when it drops back down to 0, pin 9 GPIO will be forced high. Then it's going to start counting, and when it hits 252, that's in our output compare register, it's going to force pin 9 low, and that's going to give us a 1 millisecond pulse. So over here, now when it drops from the TOP down to 0, pin 9 is going to go high, and it's going to start counting. When it hits 500, it's going to force pin 9 low, and we're going to get a 2 millisecond pulse. So that's how we get our minimum and maximum pulses, by putting values in the output compare register, which you can see here. Our minimum is 252, which gives 1 millisecond, and our maximum is 500, which gives us 2 milliseconds, and anywhere in between will give us our variable speed.
Okay, here's the code running on my Nano. It's written in eForth in interactive Arduino. So the first thing I do, I assign all my register addresses to names, and I do that here. Then next I create a word called init PWM, and that's going to set up my PWM for fast PWM mode 14. So first thing I do, I take 4,999 and I put that into the input capture register. So that's going to be my TOP. Next I take my control register A and I clear it, put all zeros. Then I set bits 1, 5, and 7. That's going to set my mode 14. Then I take my control register B and I clear it. Then I set bits 0, 1, 3, and 4. So 0 and 1 will make my prescale, divided by 64. And bits 3 and 4 will set mode 14 for fast PWM. Then I put 252 into my OCR1A register, my output compare register, so it sets my speed to 0. So when I start up, my speed will be 0. Now the next word is %. That's all you need in your code. So 0% would give us minimum speed, 100% will give us maximum speed, and 50% we just type 50 then %, and that will set, this code here will actually set it up for 50% speed. So we'll have a look at that when we run it. I'll show you that code. Now the rest of the code is just for demo purposes. That's when I was using my keyboard. I mapped it to my keyboard, my up-down keys. But for all the code that you need to run is just the word %, and we'll load that. And we'll have a look at the word % and how you could use that. Okay, I got TerraTerm up and running on my computer, and it's connected to my Nano. And as you could hear, the motor is complaining because there's no signal into the ESC. So I'll give it some signal. I'll type motor. Now I could use my up-down keys to put a value into the output compare register to give it some speed. So I'll go up. You see it's coming on. All the way to 500, it maxes out. And I can take it down. All the way down to 252, which is stop. So I'll get out of this. Now I'll use percentage. So I'll go 25%, 50%, down to 0%, which is stop. So that's all you need in your code. So it makes your coding very easy. All you have to do is just type the percentage you want from 0 minimum to 100% maximum.
Okay, so that was my little tutorial on how to control one of these motors using your microcontroller. So get one of these motors in the ESC, and you could actually use a servo controller to control it at first to get familiar with it. Then you could hook up your microcontroller, write some code. Now you could build projects, and you could control a brushless motor.